How to graph equations of the form a times x plus b times y equals c, where a, b, and c are non-zero constants by hand, two different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. Here we're going to graph 2x plus 3y equals 18. We're going to use a table the first way. So we'll create a table, and we need to find ordered pairs that satisfy or work in this equation, 2x plus 3y equals 18. We could do this by guess and check. For example, we could pick a number like 5 and substitute that in for x, and then try to find the value for y. So we'd like you to pause to answer this and then resume when you're finished. So if x is equal to 5, we'll put 5 in place of x, and then 2 times 5 is 10. We'll subtract 10 from each side, and then divide each side by 3. Putting those into that ordered pair into the table. But we hope there's a better, faster way than this. And fortunately there is. So what we'd like you to do, instead of doing this by guess and check and just picking numbers randomly for x or y, we're going to solve this equation for y in terms of x. So go ahead and do that. Pause to answer, resume when you're finished. So solving for y, first we need to do is subtract 2x from each side, divide each term by 3, and now it is solved for y. We should point out the original equation and the one solved for y are called equivalent equations. They look different, but they have the same ordered pairs. So let's go ahead and choose values for x to substitute in to find what y is. But we're going to select values that are easy to work with. So we want you to think of 5 values for x that are nice, that is, easy to work with. So go ahead and pause to answer that, resume when you're finished. So choosing values for x, we decided since 3 is in the denominator of the coefficient of x, we suggest using multiples of 3 for x values. Some positive and some negative. So pause to answer and resume when you're finished. So here are the 5 values that we selected that are all multiples of 3, including 0. We're going to substitute each value of x into the equation to evaluate for y. For example, when I put in positive 6, we get y equals negative 2/3 times that positive 6 plus 6. And then we have to go ahead and simplify that expression. So we're showing each step here. If you need to check any of those steps, press pause as needed. So we put in y equals 2, and we can then plot 6, 2. That's the first point on our graph. We'd like you to complete the table by substituting these 4 values in one at a time and find the corresponding value for y and place it into the table. Pause to answer, resume when finished. So putting in 3 for x, we came up with y is equal to 4. Again, pause is needed. When x is 0, we found y is 6, so we plotted 0, 6, and again, if you need to pause that, do so. When x is negative 3, we found y to be positive 8, and we plot that point. And when x is negative 6, y is equal to 10, and we plot negative 6, 10. Again, pause or rewind as needed. Notice that the points seem to make a line. So let's go ahead and connect the points. And that's our graph. Second way for this same equation. So graphs of equations this form are lines, and since 2 points determine a unique line, we only need 2 ordered pairs that satisfy or work in this equation. Here we will use the simplest value to substitute into each variable x and y. And that value is, well, we think the simplest value is 0. So let's let x be equal to 0. Substitute into the equation and solve for y. We'd like you to do that, so pause to answer, resume when you're finished. So substituting 0 in for x, 2 times 0 is 0. 0 plus 3y is 3y, and then we divide both sides by 3 and get y equals 6. So the ordered pair is 0, 6. Again, press pause if needed. We'll plot 0, 6, and there it is on the y-axis. Now let's let y equal 0. Again, we'd like you to substitute and solve for x. Pause to do that. Resume when you're finished. So 0 in for y. 3 times 0 is 0. 2x equals 18. We divide both sides by 2, and x is equal to 9. So plotting point 9, comma 0. We can see that is on the x-axis. And since 2 points determine a unique line, we'll connect those points with a line. Now these 2 points have special names. The red point is the place where the graph crosses or intersects the y-axis. We call this point the y-intercept. Y-intercept. What are the coordinates of this y-intercept? 0, 6. The other point, the blue point, is the point where the graph crosses or intersects the x-axis. We call this point the x-intercept. And the coordinates of the x-intercept in this case are 9, 0. The name of this second way is called the Intercepts Method. We did the first way by table. Second is the Intercepts Method. We'd like you to understand both. The advantages of using the Intercepts Method, though, are it's quick, and there's less chance of making a mistake because you're working with a nice number like 0. We'd like to investigate the intercepts so that you understand them more generally. So what we'd like you to do is copy this table onto your paper, record the coordinates of the x-intercept for each and the y-intercept for each, pause to answer this, and resume when you're finished. So please do so. All right, so hopefully you did that. So we're going to show that line G has an x-intercept at -6, 0, and a y-intercept at 0, 3. Line K's x-intercept is at 3, 0, a y-intercept at 0, -4. And the green line N, x-intercept 10, 0, y-intercept 0, 7. We'd like you to stop and look for patterns in the coordinates of the x-intercepts and patterns for the coordinates of the y-intercepts. First, the x-intercepts. Pause to answer, resume when finished. So the y-coordinates for each of the x-intercepts are always 0. So look for patterns in the y-intercepts. Pause to answer, resume when finished. And the x-coordinates are 0 for each of the y-intercepts. So we'd like you to copy and complete the following 2 generalizations. Pause to answer, resume when you're finished. So if a point is an x-intercept, then the y-coordinate is 0. If a point is a y-intercept, then the x-coordinate is 0. And you'll see that if it's an x-intercept, y equals 0. If it's a y-intercept, x equals 0. Kind of just backwards. Now you try one. Graph this equation using either method or both for the practice. Press pause to do this and resume when you're finished to check. And here's the answer with the table of values, with the y-intercept and the x-intercept shown, and then the green line is the graph.